Hello, I'm Henrik, I'm the CEO.
I'm Riccardo, I'm a developer. Actually, first title I got in ChromaWay was Code Slaver.
A developer.
Okay, yeah, what we
A random developer talks to a CEO.
what we realize is that a CEO should have a full understanding of the technology, and since Henrik is actually a good developer, at least he used to be before founding ChromaWay, it would be extremely value for him to learn RELL, which is actually our language for coding smart contracts. Okay, so I think one interesting thing to know is that we developed a plugin for Eclipse, so you can have all your favorite IDE, which I suppose is Eclipse.
No. Look at me, I'm almost 50. It's either Vim or Emacs.
Okay.
And for me, it's Emacs. No, but I have used Eclipse when I did some Java development as a consultant.
I also use Emacs from time to time in the airport just to act very, very cool. You know, like I'm on a flight and people think I'm like hacking the airplane. Okay, do you have Eclipse installed anyway?
Eclipse installer.app.
So actually one thing that you should keep in mind, and it's good that we are installing it, is that we have to install the Java version, like the IDE for Java development. Because
is that the Eclipse version that you're installing?
Yeah, you're probably asked at some point which one you want to install. So you should go for the Java one, because actually RELL, like Postgres, is based on Kotlin, which is compatible
here
with
I'm
Java.
asked Eclipse IDE for your Java developer.
Yeah.
We don't want that enterprise stuff. No.
We don't believe in enterprise.
We used to do, but now we do this cool Chromia stuff instead. Games and things like that. Decentralized social networks. Freedom. Install.
Yeah. Okay, it takes a while.
Disclaimer that, of course, Chromia can be used for enterprise applications. And we will soon show an example, but
okay.
Yeah. This time it's about the game, right, Riccardo?
Yeah.
This tutorial.
Yeah, exactly. So actually, what we can try to do is develop a very simple app, totally decentralized. So we don't have not even a central server to index emails and stuff. We can develop a tic-tac-toe. So actually, pretty simple logic, just to get hands-on on the development. And
so it is completely decentralized. You say that there is no server connecting. You have a client, of course.
You have a client, and all you have in your infrastructure is simply the blockchain that you are querying and sending transactions to, just as it should be. Okay, we are launching it.
Let's use this workspace. Eclipse workspace.
Yeah, that's the default workspace. Okay, so now we have Eclipse.
That's
Okay.
how I remember Eclipse.
Okay.
10 minutes to open it up. Yeah.
All right. So okay, we can close like the informative page probably. Now this is like what you have in order to develop your Java application.
Yeah.
But I suppose you don't want to develop a Java application, but you want the RELL application. So what we need is to install the right driver. So we go on the help tab on top.
Help.
And then we go in install new software.
Help. Install new software.
Yeah, and I suppose you randomly receive a link in the last hours.
Oh, suddenly there's a link in front of me. I can read it up. HTTPS, of course, we're a security-focused company. worldwideweb.chromia.dev/rel with 2 L's -eclipse/update ending /.
Okay, we should...
and add it, right?
Yeah, that's right.
Name, RELL IDE, something like that. Is that a good name?
Yeah. I'm not sure we need... okay. Yeah. Some point you should find something.
Unable to read repository. Content.xml. What is that? Content.xml dot. Is there a dot too much? Sun security validator exception. PKEX path building path. Sun cert path builder exception. Unable to find valid certificate path to requested target.
Just
HTTPS.
let's just put www.
Like this. I'll try without HTTP.
Oh yeah.
Can we try that? That's so much for the security-focused company. This is not a release version yet. Okay, so I'm selecting it here. RELL.
Yes. Sir.
Next.
And yeah,
Finish.
can finish. And now we have to restart Eclipse. It would actually pop out an alert asking for it.
I have to restart.
No,
Eclipse.
no. Now it's downloading. Here you
Yeah,
see in the bottom. When it's done, it's possible to use it. Okay. Maybe we can talk a moment about the forum.
Unsigned content. That's okay. Install anyway. I trust my team.
Yeah. And now
Yes. Restart Eclipse IDE.
Anyway, you were like a master SQL developer, right?
Pretty good, yes.
That's what legend says. So RELL is actually a language that is pretty similar to SQL. That's what we try to address. So essentially, we use all the relational concept of SQL. So I hope you will feel yourself at home.
Yeah. Disclaimer though, SQL is kind of a beast. It's not the nicest language on the planet necessarily, but it's very powerful if you know. But it's kind of quirky. I hope that we remove some of the SQL quirks.
What I like to say, but it's just my quote, is that RELL is like SQL written in the 21st century.
Oh, that's so pretty. That's so beautiful.
But it's actually more compact than normal SQL and more readable. Actually 7 times more compact.
Oh, fantastic.
I think you need...
Fantastic.
I think you already knew the 7 per more compact because that's what we go around bragging about. But now you can see that it's actually true.
Yeah, I also say that it's easy to learn. So
let's find it out.
Yeah, let's find out.
Okay, so we can close the informative page.
Cool.
And you can create a new project.
A Java project or create a project? No Java project.
We go on top in file. Oh no, let's go just on top. New. And then project. Here we
Not Java project, but
no,
project.
Just a project, exactly. Here we have like different things, and one of them is RELL. So
cool.
Yeah, we open the folder.
RELL project.
And we started. The name, we can call it tic-tac-toe.
Tic-tac-toe. Is it my workspace? Cool.
Okay, I see you like a camel case. I was using the dash. Oh, you can really use what you want. I just noticed that I was using dash notation. You were using camel case.
Yeah.
Yeah. You're really free. You're really free to do what you want.
I thought this is Java, so let's do camel case. I don't like it, but whatever.
Okay.
RELL perspectives.
Yeah, so let's open it. Okay, now maybe we can explore a bit this repository.
It looks like normal Eclipse, right?
Yeah. The first thing we can see inside is a folder called RELL.
Okay.
And inside we can see the different folder called the source. What we have to do is create a new file.
So do I double click on source?
Yeah, right click there, new file.
Yeah, right click, that's new file.
And we can call it main.rel.
Main.rel. Does it have a special magic property to be called main?
Yes,
Like in C or something.
not particular in RELL. In RELL, any file can be the file. You can specify which file is the main one.
Yeah.
Like a sort of a package JSON, like in
Yeah.
Node. But we have some powers in this ID, and we can directly access main without settings. So we're gonna do that.
Okay. So I finish.
Yes.
Find your main.rel to else finish.
Okay. Now maybe before starting really talking about tic-tac-toe, we can say what is the first thing that you do when you want to learn our language?
You go to our homepage and go to the documentation. No?
Yes. And you try to do a Hello World program. So
Yeah,
you try
okay.
to display
Hello World. Yeah. Hello World.
So we can try to do that and just display so we can see how we can run a node.
Okay.
So we can run the node and we see display something.
But it's not easy to do Hello World in SQL. Seriously. Is that inserting Hello World into
That's true.
a table?
We can actually just display in console a message Hello World. We have this possibility. To do that, we need an operation. Okay. So essentially, in RELL, we have two main constructs. It's like the class, an operation, and a query. So that's true.
Yeah, and the class is basically analogous to the tables in SQL.
Perfect.
Or relation in relational algebra.
A class exactly matches a table. An operation we can say it matches stored procedure.
Yeah. So we basically focus on updates.
Yes, inserts as well. Yeah.
Changes.
Yes, and then we have queries, which is exactly a query. It's exactly a query. Yeah. So if we write an operation, it's something that we can call from outside. Yep. So it's a query. But a class cannot be called from outside. So we're gonna display a hello message, a hello world message, and we create an operation. And this is also important. We need to call it main. So
operation main
is a sort of public static void main.
Yeah.
For Java. And we can give like 0 input. So we just open the parentheses and close the parentheses. And then curly brackets. And and then we can start writing our code.
I would like to have a new line here. Is that okay?
Yes.
Wow.
We are not space sensitive and stuff like that. So we can just write printer.
Print with print.
Yeah. Or you can also do it with log, but we'll do it with print.
And double quotes, single quotes? Or...
You can decide.
Really?
Yeah, feel free.
I'll do double quotes. And
we need to open the brackets as is in a normal.
So it's like a function called something like that.
Yes.
Print hello world.
And then we need a semicolon.
Semicolon.
Yeah.
Okay.
Now, if we did everything correctly, we can save the file. Then right-click in a main.rel file on the left sidebar.
Right-click.
Go to Run As.
Run As. RELL console app.
And here we can decide. We can have a RELL console app, which is what we're going to do now. Yeah. And it's very, very simple. Does not really involve a big decentralized system. It's just like entering the main and executing all the code in the main. So it's very useful to test stuff while you develop. We have a remote postchain app, and this is something that will be available in the future, and it automatically deploys a network of nodes. So you can have your blockchain in a snap. And a simple postchain app deploys a single node that can be run in your IDE. So if you have your game developed in other platform, or you have like a JavaScript application that wants to contact the postchain app, you can just do it.
So basically for development purposes, simple.
Yes, when you start having like not only the RELL part, but you want to develop something with a front end. Yeah, you probably need the third function. But
when you want to do like a full blockchain that is decentralized, it would probably be the remote.
Exactly. Yeah, even for testing might be useful.
Yeah.
But yeah, for now we're going
Console app.
call RELL console app.
First one here.
And if we are
here
we can see hello world.
Terminated. Hello world! Exclamation mark. Exactly like I wanted. But I changed to Swedish maybe.
Hey RELL.
Hey världen.
And then is when we find out if we support.
Do I need to save it?
If we support all the characters.
Yeah, but this is like a Unicode test.
Yeah.
And I do it again, right? Run this RELL console.
Yeah. I actually already tried it, by the way.
It opens up to the whole world to do programming.
Yeah, so let's do something more interesting, maybe.
Yeah.
Now we
get rid of this.
Set all
I guess that operation mains stays for a new app.
Yeah, we can keep it for debugging now and then stuff. I will go a bit. I will explain probably notions where needed, but in any case, there is documentation on our website. So, like in any.
And what's the web page?
Maybe we can.
Chromia.com. Links to.
You can access it via Chromia.com. We have a developer section.
Developers.
And here where we go.
Yeah.
We have a quick start that teaches how to install the Docker. So we also have a Docker container where you can have a single node.
Yeah.
So actually something interesting to be mentioned. And then we have like the main documentation after the tutorial, which is database operation, library, and general language features. So these three are actually as a
tutorial first. General database operations and client-side library. The library and the client-side library difference.
Yes.
Yeah. Client is how to connect.
Is how to connect a JavaScript or a Node application. Is essentially two functions. One you send the operation, one you request for queries. So
this is the built-in library, so to speak.
Mm-hmm.
System classes and functions. Database operations.
This explains like the syntax of create, update, delete operation, and I would say there is also the selector, which is the cardinality. So actually, it's
the at operator.
Yes.
So create, read above, update, and delete.
Yes, exactly. Actually, maybe there is a question that we receive quite often. Is like, how can you delete statement in the blockchain?
How I can delete things in the blockchain? Yeah,
because if you delete things in the blockchain, it means that the blockchain is not immutable.
No. Should I explain?
Yeah, go ahead.
Because, you still have a sequence of what led up to this deletion, and you have a logging of who removed something. So it's still something that is distributed among the different nodes of the blockchain and validated. So for this is the current state, basically. You do a delete, but that's a logged change.
Yeah, I would say actually this is actually one of the definitions I give about blockchain. The blockchain is like a way to keep a global state consistent at a given block. Yeah. So all our SQL tables that are not transaction and blocks tables are essentially the global state of our blockchain. So all the state that is kept in a decentralized fashion around the node. But the things that never change is the history that led to that state, which is in the blocks and the transaction that happen over the time. Okay, this was like the definition part, like kind of let's get it a bit started.
He's not only a developer; he's a philosopher and a talker as well. So.
That comes with the full package. If we're gonna make a tic-tac-toe game, we probably need essentially a player. So the person that plays, the table. That's all essentially like the paper where we're gonna draw our tic-tac-toe game.
The board.
The board, yes. Then we need a sort of table to join a sort of SQL table to join the table, the board of the tic-tac-toe with the people that are participating into the game. And I will say pretty much it.
Yeah. Should we start with the simplest, a list of players? Or
I think players will be a good way to start. So we create a class. A class is essentially a table. So we can really think at it like in the same way we think when we create a table in SQL. So we can write a class.
Well, this is the SQL then. So some create table, but now we create class like this.
Yes,
class.
but
just class.
Yes, just class. Why you need to create it?
Yeah. Implicit definition of a class. Yeah.
Yeah. So
curly brackets or
curly brackets, exactly.
Yeah.
And then we have like the normal concept of a primary key and a foreign key. So we want a key is unique, like in SQL. And then we have also interesting to be mentioned index. Index is indexing your results like in SQL. So when it's a key, is also indexing. And we want the name to be unique of the player. So we can say key name. And yeah, semicolon, perfect. And this is defining a column name.
Yeah.
Now,
and a primary key name, which means that there can not be more than one Riccardo.
Yes, exactly. Or one or more Henrik.
Yeah.
Now, interesting to note is that in SQL, you have types. Yeah. And in this situation, we don't. This is because we have some types that can automatically infer the type. We have names, we have like variable names that can automatically infer the type. So name is always a text type.
Because it's called name.
Yes. We have also public key.
So we are guessing a little bit that name is something that's going to be used in a lot of applications, and then we guess that it will be a text field.
Yes, exactly. And we do that with different keywords, such as timestamp, public key. Public key is a byte array, name, and a few other words which are in the documentation. It is actually, I understand that it might look confusing, but I can tell that the majority of the variables I use are actually not typed, like automatically infer typed. So indeed, the second column we need in this table is public key, because one user is identified by the public key that he has. So we have another key.
Is it an underscore public? It's also a key.
It's a key, yeah, and it's a pub key, like PUBKE.
Pub key, like this.
Exactly.
That's the magic word for a public key.
Yes.
Now we know that's specific.
A note that if you put a colon after a pub key and write a byte array in a byte underscore array, the space is not needed, but I think it maybe helps the readability.
I don't have a space, right? Pub key.
Yes.
Do you think I should?
Yeah. It works. It doesn't complain still.
Because it is actually a byte array.
Yes.
But if I call this, you have integers, right?
That's I'm afraid it will stop the execution.
Okay.
So we can just leave it with a semicolon pub key, and
just like this.
Yes.
Implicit byte array.
Yes.
Those are. Don't we need a name for the class, right? Here, class players.
Yes, player. Oh my god, I can't believe that we missed that. Yeah, so we have a class player, name, and pub key. And this is how our table is defined. We can create now another class, which is the board.
Can we call it board then?
Yes. In my code, I call it table, but I think board actually makes more sense. And yeah, so we can give to the table a name, so to uniquely identify it. So we can set.
Should that be a key then, or should we have?
It should be a key, because you don't want to select a board and then receive 2 bags from the database.
Yeah, identify name again. Yeah.
So you're using name again, exactly.
But this is a board name, not a player name.
Yes, but the way you access it is like an object.
How do you name a tic-tac-toe board? Like, what's the name?
I usually
The little wooden board.
I actually lazy and I use a timestamp. Okay, so we need to know
coordinates or something like that, or how do we map it out, like X and Y coordinates?
Like okay, yeah, you mean like the display of the table, like cross and circles and
yeah,
empty.
I mean, how would I represent a board in? I would represent it with probably spontaneously with coordinates X, Y.
Mm-hmm.
How would you do?
I did just an array of nine elements.
An array of 9 elements.
Yes.
Okay, so each board always has one, and you always represent it as an array. Can we have an array in a table here?
Yeah. No, we can have a list, but maybe what we can show is how to cast from GTV, which is our data representation, and how to cast back. So we can either decide to use a class for that. So essentially, we can make a class that is referring to one board, and it's keeping the index of all the cells. Or we can decide to go for the easy way and just have a list of 9 elements. I will go for the last one, maybe.
The easy.
Yeah.
And the difference between a list and an array here, what according to you, is not much.
We don't have an array. We call it a list.
Yeah. So it's basically the naming.
Yeah, it's a. Yeah.
And we call it list.
We can call it cells.
Yeah. So it's not the key. So first is the name cells.
Yes.
And a data type.
This is a list of integer.
So it's a parenthesis. Or
list, and then you have like the diamond.
Diamond.
Like a diamond is like the lower than and greater than.
Do I have a sheet?
I don't have it actually.
Lower than. Like this.
Yes.
It's
integer.
Java-like.
And yeah, so pretty much it. And we need actually parentheses to declare it, like it's sort of initialization. So
afterwards.
yes,
Okay. So initial value is an empty list here. Or should we have it? Should have it empty? Or should
we cannot store a list into an SQL column unless we store it either as a GTV. So we should put GTV value.
Yeah.
Either we make a different class, which keeps a record of all the cells. That's why I believe that it was good.
I would say that one board.
That's why I believe it was good to have a GTV value, which essentially creates a representation of an object, of a class, but without storing it as a table. So it just stores the representation sort of like a JSON value into the column.
So it's basically serialized.
Yes, exactly.
Something.
Exactly. So to do that, we can define it. We can define it as a record. So record is essentially a class that does not exist in the database. So that does not exist as a table. So we can go on top and on line like 5 and create a record. And we can call it cells.
Is it like in defining a new data type? That's usually a complex data type record.
Yes,
right?
And we need to use the since we are declaring it
Cell,
as if it's a class, so in the same style.
Okay.
We have the curly braces.
And a name? No. Name.
The name is cells. And inside we put the list of integer called cell, like the list of the cells.
Yeah. Okay.
Yeah.
So we have a name on the inside here.
Okay. Yes. And in cells we can store, like in the line, we need a semicolon at the end. And
no semicolon here.
Yes.
We got help with that.
Yes. And here we can just write cells. And like without a semicolon. It's without the
So we have the name cells
here.
here.
Yeah.
Cells here.
Yes, we just write a byte underscore array. Okay.
So it's basically a blob from the client, no? Or from
Yes, because essentially we don't need any to check any data inside the cells. What we do is get a change. So like the client says, I want to change X these cells. Then we write the code that we get the byte array. We convert it into GTV, or like we convert it into the record actually now. Yeah. And then we change it.
Yeah.
All of this in the blockchain side, and then we put it back into the database. We can put it. It's fine to put it as a byte array and not as a different class, because we are actually not going to perform any query on the displacement of the cells. If not, when we open it from changing the value that is inside. We can actually create a table with it, a table that which we can also create a table of cells belonging to a board.
Yeah, I will have like an index somewhere, cell number 1 to 9 in a class, I guess.
Yeah, that's also possible.
But who am I to judge here?
No, I actually agree. I think I was just too lazy to create like things a bit with a different class, because I can just throw the array inside and pull it back.
But maybe it could be an exercise for me later to change it.
Okay, then in the board, actually, interesting thing. Many column, many records in a table in SQL are usually not mutable. Like they can be mutable, but the person that designed the database does not want it to change. So, for example, in this situation, the public key does not change, and in this situation, the name does not change, neither in the board, neither in the player. But we want the cell to change over the time. So the value of the cells need to change over the time. Yeah. So we need to add a keyword in front, which is mutable.
Okay, so by default, it's not mutable. So
yes,
we cannot delete players.
Exactly. You cannot change the value of players.
I can delete them, but I cannot change the name.
You can change a record, but you cannot change the value of the record if you don't specify so.
Yeah.
Also, we need to know whose turn, so we need basically a signal of who is the next player that needs to make an action. So inside board, we can have another variable, which is like mutable.
Yeah, it needs to be mutable, so you can change the player
and
turn or
player. Turn, or we're actually going to store
next to play next turn.
Yes,
current play. Maybe what is it the current?
We use next to play because so we can verify easily the public key. So if the public key of the one that is that has to take the turn is the one that sends the transaction.
What's the coding standard? Are we using camel case or underscores?
We use underscore because in case you want to check the data on the SQL database, which is totally possible, it's totally allowed. You can have better readability. Because
so next player, is that good?
Yes, but you need to say what is the next player. So the next player is actually of type player.
Like this.
Yeah, and here we are creating a reference. So we are saying that when we go to check the next player, we actually have to check the reference in the table player.
So this is a foreign key? Or
yes, it's exactly. It's a foreign key. In SQL, we actually create a foreign key. And then we can have like a mutable, another mutable, which is the state. So with this, we identify if the table has the player already playing, or if it's waiting for a second player to join, or if the game is finished, and so forth. And we can make it...
You're calling it state, is that like a numeric or enum or something?
An integer, yes. If we want, we can also index it, but yeah, maybe we can do it another time. Because so you can have all the games that, for example, are ready to be played. Stuff like that.
Let's do it when needed, I would say. But I would like to document the different states. How do I make a comment here?
Yes, of course. You can just have a
double-
double slash or
Yeah.
slash and the star.
Have-
We can have maybe 0, which is a player is a table without a second player, because of course the first to make the table is also the first player.
Table without matching player.
Yes.
Opponent, right?
Yes.
Or
Okay.
is that you always have one player?
Like to play tic-tac-toe, we need 2 players. If you create the table, you're the first one.
Yeah, but it will always be at least one player.
Yes,
when
exactly.
you create the table. So
Yeah.
opponent, table without matching opponent.
Yes. Yeah. And 1 is when we find the opponent, and let me see.
One table.
So now what we have, we need another table, which is matching, referencing the board and referencing one player. So in the moment that we select a board, we know who are the players and so forth. So
player game or player underscore board or something.
Yeah, okay. Or player. Yeah, it's fine.
Do you have a convention to call this? So
No, we don't have a convention.
Player to board.
I have player at the board. Yeah.
Player at board. That's good. That's even like English.
I'm not sure about that. And so we need to know
of course,
a board.
Since I have wrote player first, I would first need the player, right?
Mm-hmm.
So the name should be player,
and we need
the data. Oh, do you want the name?
No, we
now we have a name on both. Our player is not a name.
We can actually we can say that we want as a unique key the player and the board together. So you cannot have the same player on the same player on the same board. So we can write a key.
Before key.
Yes.
Player.
And a comma. And this is saying that the key is shared by the player, like it's the unique key of player and board. So we can write board. And semicolon.
So you cannot be a player at the board. The same player cannot play against himself.
Exactly.
But he could play different boards. Actually.
Yes, of course. Yes, that's allowed. Yes. And then we should.
But we need the data types here, right? No, it's not.
Because we get it from there. And then we also need to select what is the sign.
But it needs to be board here. If I write game, it would be incomprehensible. Like it needs to be.
You can write game
name as
you can write
board.
You can write game, and then you put a colon board. That's totally legit.
Yeah. Okay. But we named it board, so let's call it board.
Yes. Yeah, but you can call it game. You can.
Or should we do it just for player at board? But okay.
And then we also need to select what is the sign of the player. So if he's gonna use a cross or a circle.
Yeah, that could be in this table as well, right? Player at board.
Of course. So we can, but it must be unique. Like one table must only have one X sign and one circle. So we can have a key, which is a board and a sign. Actually, no, it's not a key. It's okay. Let me think a while. Yes, I would say we're safe in saying that.
Should we throw everything in one class? Maybe it should be second. Second one, right?
It's actually quite handy, because then you can get the player table, and if you want to assess the sign, you just do player table dot sign, and you have it.
What is it? Side. Right?
Sign. I don't know. Actually, I don't know actually if it's
okay.
English.
Sign. You mean X or 0?
Yeah. And we can make it integer maybe, or we can make it and it's like must be 1 or 2, where 0 is empty. So, for example, we can have the sign 1, which is cross, the sign 2, which is circle, and sign 0 is empty cells.
Or symbol or sign.
Yes, symbol maybe. Probably symbol is better, probably.
So, a player at the board. We don't need any uniqueness here on the symbol.
We actually might need it, because we have to be sure that the person, that you as a first player, you select X, the cross, you select the cross, and we have to be sure that I don't select the cross as well. So the board might only have one cross and might only have one circle.
Here.
We can define it in one line, or we can write the key, board, and symbol in a new line.
Here.
Yes.
Key, board.
That's correct. But you can also, like, if you wanted, you can put it in one line: key, board, comma, symbol, colon, integer, and semicolon. That would be legit. But of
Same
course,
thing.
Yes. That's legit. Okay, so now we define the classes. So maybe we can create the first operation, which will probably create a player. So, okay.
Create player.
Yeah.
And then the client will send in the pub key, right?
Yes, we need a public key and the name.
Let's start name and public key, I think.
Mm-hmm.
Data types determined using these magic names, right?
Exactly. But for example, if for your convenience you want to call it
I call it player.
Player name or player.
Player name is a string.
Is a text. That's totally legit.
Let's do this.
So in this situation, what we need to require, what we need to verify, is that the player is actually the one that signed the transaction. So we have a function that is called require, and verify that an if clause, like if a comparison is true or false. To do that, we have require, and we can use another function which is called is_signer.
So require
is fine. Like require evaluates a comparison.
Okay.
If it gets true, it proceeds execution. If it gets false, it stops the execution.
So top require, and then inside here then is
signer, and we set the public key that we received. What?
So
yes.
It means that only the client, that the message sent to the blockchain is signed, and then we verify that the signed message to the blockchain and the pub key that we receive in the create player operations are the same.
Exactly. So exactly that's what's happening. Like when you send a transaction, this is signed by you, by your private key. And when we receive the transaction on the RELL side, we have to verify that this information, this function that is like creating a player with the name Henrik and the public key, which can be from whoever, is actually the same public key that signed the transaction that I received. And we can do that with this function.
Okay.
And very easily, then we have to create a player. If this is true, we can just write create and player, and then we'll put the parentheses. Yes, okay.
Now I want to assign here. I did this trick to call this player name. So I want to send in name is player name. Is that correct?
Yes, but you can also directly write player name, and what RELL will do is verify the type of the input that you sent and match it. So if there is only one type string, you can just put it in and it will automatically assign it.
So if I would have more than one field here that are text, then it will not be able to defer to.
Yes. So what we have to write inside the parentheses is a dot name. So dot name says access the attribute name of the class player, and then equals to player name.
So that's,
if you write
this is okay.
This is okay.
But I could also player.name equals player name. This assign.
Without player, because there is no really necessity to write player. We can just write the name.
Because I'm implicit here.
Exactly.
Okay. So the field.name
equals to player name.
Assigned to player name.
Exactly.
And this is deferred as well.
Yeah, you can write
a field called pub key.
Yes. But if you put the dot, then you have to you have to specify.
Do this to trick it, but that's kind of meaningless. So let's use the nice.
Yeah, so you can have actually much more readable code. Actually, the problem that I personally had is that I was making sort of smart contract to SQL, and I end up with a file of 4,000 lines. And actually, it's pretty helpful when we have 7 less purpose.
That's one of the known facts of programming and bugs is the few lines of code. So, well, number of lines of code is the only scientific determination of basically quality and the number of bugs. So that's good.
Yeah, and also amount of time you work on your code, I guess.
But all the others, like the complexity measures are extremely correlated to lines of code. Lines of code explains everything.
But I guess that now if people start using RELL, they will go to the boss will come and is like, oh, now you're writing less code, you should get paid less.
Oh, yeah, of course. You pay per
line.
Code.
Okay, we now set a player. Probably at some point we should create a table. So we can have an operation that is create table. And what we need to know is the name. So table name.
Yeah, we can call it table names.
Yeah, actually it's quite useful here because you also have a player name.
Yeah. Table name text.
And player name text.
Oh, yeah, okay.
Note that we can also use the public key instead of the player name, since they are both unique.
Yeah.
But yeah,
whatever.
They are not mutable.
Maybe public key might be.
Yeah.
No, but this is nice. I don't know. It's nicer when you debug, maybe. I don't know.
It's it doesn't really matter. I use it in. I actually use it the Ralph tic-tac-toe for making a RELL tutorial, and it's kind of more intuitive.
So this is easy for me. I will just do create. You call it create table.
Mm-hmm.
that's very much SQL. Like.
Because I created I call it table.
I will call it board. Create board,
and
I will. Don't tell me here, but I will do .name equals. That was the board name. The table.
Yes, exactly.
For some reason, we call it table name here, but that could be refactored.
Mm-hmm.
And we had next player. Interesting. We don't have a next player. Why? How is the? It's player at board we should do, not the board, right? Or should we do 2 inserts? Let's do player at board. The next player, let's have this as the first player. You're first.
Exactly.
So next player is the player name.
Next
but
player.
What's
next player is expecting a player type. So we need to make a query. Now we can make it in a line query, so we can make a query here. But maybe we can go in a new line, and so we can talk about how we make queries in RELL.
So should we make first the query to be like here?
You can make it in line, but just as we can talk a moment about making queries.
Can we do it a local variable here to do it?
Perfect. We can call val value, and the value is player 1 maybe.
Player 1 equals.
And here we make a query. So we need to find in the table player, one player with the player name.
And I cheat because I know that we use that sign somewhere, but I don't know where it is.
We were on the right track. And then we have like the curly braces.
curly braces. And then we need to index it with name.
Yes.
Equals.
So
Dot name.
equals, double equals, player name.
Curly brackets, semicolon. Okay, and next player then is player 1.
Note that you could just send the player name without doing dot name equals player name. You can just say player name.
It will defer it automatically on the
Exactly.
type.
So when you have to read,
The
it's
only
actually
text
super easy.
field. The only text field.
Yeah.
And then I can do it inline as well, if I want.
Yes, you can do it in line. But actually, we need to verify that the player 1 signed the transaction. So before creating the board, so we don't have to go on the database, we can first verify that the player signed.
First, we have something problem here. Dot name equals statement. Next
is missing the list of cells. So it's missing actually one.
Yeah, mutable cells.
Yeah. I'm missing a couple of things.
Do we do it like this?
Yeah.
Cells is lighter. How do we initialize that?
We can initialize.
Send it or no?
We can
send it from the client. Or?
No, we don't want to send it from the client because the client could send anything. So since we created a record a few lines above, we have a record cells.
Yeah.
We're gonna use it and create a record of cells with 9 zeros, which represents 9 empty cells.
How do I create a record?
You write the name of the record.
Cells.
Yes.
Then parentheses.
Parentheses, yes, and then we write.
What do we have in the cells? We have a state, I guess.
Yes. So we have to send
states.
all the parameters. So, for example, if we ask for a text, we can write a string. But since we have a list, we can just write array like the square brackets. We can just have the square the circle.
Okay.
Okay, wait. If we want to create a record, we need the name of the record, so cells. Yeah. Open circle parentheses.
Circle parentheses.
And then we have to set the variables.
Yeah.
So the variables that you want to set is an array.
Yeah.
So we write square parentheses.
So this is an array.
Yes, and
with 9
zeros.
Zeros, and zeros will be an empty spot.
Cell, yeah. And field size cells is expecting a byte array. Now we can convert this into byte array. So we can just write.
This needs to be a byte array.
Yes.
No, cells here.
Yes. So before the semicolon at the bottom, like under cell, here. We write 2 underscore byte array.
Like an operation.
Yeah. Dot 2 underscore byte array.
Underscore array.
Actually, I think it's 2 bytes. It's like I'm actually going by memory. It's like 2 without underscore, capital B, bytes, and then open circle parentheses and close circle parentheses.
2 bytes.
Yeah. And then.
Okay. Cells 2 bytes is deprecated. Use 2 underscore bytes.
Okay.
Oh, what a nice interface. IDE. It tells me stuff. Fantastic.
Okay. Okay.
Complaining here again.
Yes, because we are missing state.
Next player.
We need the equals here.
Cells should also be
equals.
Yes. What do we have? State, right?
Yes. And here we need the column, the comma.
Yeah.
Yes.
Yeah. State 0, whatever that was.
Perfect. And we don't need the semicolon there. Okay, every time we have to talk, we have to deal with bytes. I start sweating for some reason.
This should be dot, right? Dot
yes.
Cells.
Yeah, we can actually.
Dot state.
There are all different types, so we can just send all the parameters like in a normal function. So like a text, player. There's line 41 is text, line 42 is player, line 43 is byte array, and line 48 is integer. So we could just send all of them without assigning it. But in this case, I actually agree. It increased the readability of the code. Now we want to add a player also.
Yeah, should we do that in the same operation? We create a board. No, a player. You can be player first, right? I want to play.
Yes, you should be inserted as a player.
But this
directly.
player at board, right?
Yes.
Then that could be done here.
Yes, but we also have to call the same function at some point in time.
Maybe not necessary.
When we add the second player.
Yeah. So it depends on the client how it's set up. Yes. Maybe not complicated, then we should have a separate operation.
We can have a separate operation, but is actually one line of code.
Okay, whatever.
It makes sense to create a different functions. Actually, we can introduce function. Function is an operation that is not.
I meant a different operation to have the basics, so you can make a flexible client.
Yes, but an operation is callable by a client, by transaction. Functions are not callable by people. By normal people, can only be called by the smart contract. So in this situation, we might have a function that creates a player.
Yeah.
And that creates a player at a board.
Yeah.
And then use it when we create the table. So you create the table, you have been added into the board.
Yeah. When you create the board, you are added as the first player.
I want to enter the board as a second player.
Yeah.
I make the checks that I'm the second one, etc. And then.
Yeah.
And then I call that function. But since it's actually one line of code to create a player table, it doesn't make that much sense in this case, I believe. We can make it make it like this. Of course, for in the future, if we make at some point in time adding a player becomes more complex, we might want to have a function instead of create a table. But just for the sake of this tutorial.
But I kind of like create board creates a board, doesn't create other stuff that you need to read the code to understand. So
yes, so we can have a function that is create board, and a new operation that is create board with player.
Yeah,
we can do that, and it's just required to change operation to function.
So I change this, yeah.
And
I do an operation. Player, and we need this is what we need.
Yes, and actually what we can do is have player 1 identified, like we can get player 1 in line 52. So we verify that the signature is correct, because we didn't do that before.
Okay, so we verify here.
So we get this
require is signer.
And then
we need the pub key here.
Yes, so what we can do is take the line 39, cut it.
You have it before, require.
Yes, and we don't need it here anymore. And instead of sending player name, now we can send the player itself.
Yeah.
We can call it player 1. Or change it as we prefer.
Create board with player name, and we get player 1 and require
is signer player 1 dot pubkey.
This is a magic, right?
I know.
The pubkey. Let me see. No, you're reading from the player class or table, the player, and you previously sent in the pub key, identifying itself, and now you're checking the message sent in from the client.
Yeah.
Cool. Semicolon, and then I create board. Now I assume that you will guess the data type, so we'll just call it
table name.
Table name and player 1. And it will understand that.
Yeah, with semicolon.
I understand that player 1 here is mapped to player here, right?
Exactly. Yeah. On line 51, just to say what we did, we got the player name, we went on the table with the player, we got the public key of that specific player name. And actually we got all the records. We have a reference. Player 1 is actually holding a reference to the row ID in the player table. So each table, each class has a hidden field which is a row ID. And this is what is passed as a player object. Like this type player is actually a row ID of the player table.
Okay.
And when we go to check is signer, we get the reference to that row in the table player. Then we do dot public key. We get the attribute public key of the table, and we verify it. So now we have a board, and now we want to add a player. So we can have a function that is like add player to table.
Add player to
board. We call it board.
To board. We just call it it's an internal function.
Yes.
Not called from the outside. Add player to board.
And it receives the player and the board. So actually, what we can do, we can
player. I'm sorry, I'm not listening. That's why. Like this. Create.
Yes.
Brackets. No.
No. Maybe you don't have the what he complains about. Let me see how we instantiate player at table. We're missing the sign. We're missing the symbol. We're missing the symbol. So
we're missing the board. No.
We have the board. We have the player. We need the sign. So we can say that sign is 1, but we need to send it. Sorry. Symbol.
Then I just do. It will differ. It will understand.
No, we won't. We have to send it as a.
Really?
As a
useless.
No, it infers from integer. It infers that it's a symbol, but we have to say what is the symbol that we want to use. So we have to send it as an input. As an input here in the function, we also have to add symbol. So we can just say symbol and type integer. And the symbol can just write symbol that infer everything. Now, one thing that we can do, actually here there is a problem if we call add player to board in the function create board with player.
Create board. Yeah, we should use it. Really, right?
Yeah.
What do I have? I have the player. Board I don't have, right?
But we can return from the function.
This create board.
Yeah. So we can make val board
B like this.
Okay.
B.
And we just send B.
And symbol
is 1.
Okay.
Because 0 is empty. So
no, I called it something else. Symbol 1x 0. Yeah. So let's do like this.
Okay.
2 0 empty.
Okay, makes sense. Now this doesn't work because the function is not returning anything. So what we have to do is add a return after create board. Before create board.
Here, what does it say in an error message here?
Yes. We can check the error message here.
Expression for B returns nothing. Aha. I understand. And do I do return here?
Yes, return.
Okay. And then I don't. Do I need to declare data type?
Yes. So here, after the parentheses, we write colon, perfect, board. Perfect.
This is nice. It's really good. This is better than SQL.
Okay, said by the CEO. Okay, I think I would be very embarrassed.
I mean, it's not hard to do something better than SQL, but this is.
I would have been embarrassed after this video. You were like, I actually don't like this stuff. Okay, wait, I kind of missed the flow now. I don't know if we made all the checks, but maybe we can keep going.
Create board, add player to board. That function doesn't need to validate anything. Here we have require. The operations basically need require. Most of them, right?
Yeah, in general, I try to make all. You can put require function into the require into the function. You can call it require into the function, but in general, I try to have all of them in the operation.
Yeah.
Then, of course, there are some requires that cannot escape. For example, if you want to check, is a signer itself is a require. So is signer itself as a inside as a require that checks if the publicly passed is the same as the transaction. But in general, it's better to have as much as possible in the operation. Yeah. So now we need an operation to add the second player. So second player joins or something like that, and there we will go to call add player to board.
Yeah. Okay. So join game or something.
Join game, maybe, yeah.
Or join board. You call everything board. So.
Okay. And yeah, we have
So we have a player.
A player name.
Player name.
Which is a text. We don't. Yeah. And the board name. The board that we want to join.
Text as well. And
so first of all,
same get the player to validate. Right?
Perfect.
Copy.
We can actually create a function which is get player and verify signing. So in one line we can have the player and verify that he signed the transaction.
Yeah, refactoring you can do later. So I get here, I read up the p variable, or I initialize the p variable with something from the player SQL table class, selected on the player name.
Yes, so now we verify that, and we also now we verify that the user exists and that the user signed. We also need to verify that the board exists, so we need to select that.
Okay. B.
Do you know what you can do in case you are not sure that the board exists? So you can have a nullable. Maybe we can.
Why do I need?
No, we don't need it now. I think maybe we. Okay, let's finish this.
Let it crash if it doesn't exist, right?
We can have.
Let's say board name.
We need curly braces. We need curly
board.
We need curly braces.
Like this.
And then we can add player to board.
PB.
And the symbol, which as a second player we can hardcode it will be true.
The symbol. So the first one we said would be. Oh yeah, the first one should be an X. The second one should be an O or whatever is it.
So we can just say true. And since this logic is hard-coded into the blockchain, there is no way to escape. So the number will only be 0, 1, or 2. I cannot like change it somehow. Okay, so we can make a query. And guess what word we have to write now? Query.
Select.
Maybe.
Query.
Yeah, this is also like, why should you write select if you want to make a query? Okay, no, I'm saying something stupid.
Yeah.
So the query can be get bold, and we give like no inputs. Like we want to get all of them completely.
So don't
If
need
we have
any
1 million bolts, we
like
will
this.
get all of them. We need parentheses, yes, we do. The circular parentheses, and then we open the square like a normal operation, like a operation before. Inside the semicolon, we can write. Inside the curly braces, we can write our.
Yeah,
logic.
we need a parameter to get. No.
No, we don't need it.
No. So no parameters, and then curly brackets, and then we do.
Yeah, but we need
return.
a return.
Not all code paths return value.
Yeah.
Ooh.
So if we write.
You analyze code paths.
Yeah, we can just write a return.
That's cool.
Hello, and then it stops complaining. But we can make it complain again.
Yeah, I will do an if statement here. Like.
Oh, I
don't know.
You can do it. It works.
Complain.
It
How
works.
can I complain?
You can make it complain, specifying the type that you are returning from the query. So a list or a single board or like.
Okay, so it's untyped.
It derives the types based on what you return, but for like in the future.
Do we have like a switch or if statement?
We have a if statement.
Okay.
If
parentheses.
We can write maybe a parameter here, like a input, like a if
true.
Okay.
Is it like a JavaScript syntax or?
Yes. Is a Kotlin, so else.
It's not exactly JavaScript that invented this syntax. Sorry, but yeah. So this is now I'm gonna mess up and have a code path that doesn't return a value.
You know what you can do?
Yeah, not all code paths return a value.
You can return a different type. You can return an integer now.
And now it returns a value.
Yes, but yeah, instead of a string, let's return an integer. Only in one of the two. Only when the one of the two closes. So we remove.
It complains about the spelling.
Yeah, there's Eclipse. That's Eclipse.
I would call it him. Hello and him. Get rid of it. But it's nice that we did analyze this, mainly for quality, number of bugs, etc. To analyze the code paths and make sure it can preserve.
Try to return an integer now. So on one in the if we have return a string and then we return an integer. We need a semicolon now. It will complain because it's a different type.
It's integer instead of text. So it first derives text.
But
so it goes first.
Let's say here in the after the closing parentheses we put column and integer. Now it complains here.
Checks the data types. What does it say? Return type mismatch text instead of integer.
So if you return 42, which is then the answer to all the questions.
So basically, you cannot
fuck up.
You cannot do the DAO hack here because you have quality code. Is that correct?
Yeah. I mean, that's quite interesting because SQL does not perform any check on what you get back from a query and stuff like that.
No.
But in blockchain, we want security.
Yeah.
And we want to have we cannot have A/B testing or like fast releasing and release code 3 times a day.
No.
Because it's very difficult to change a smart contract once it's published. So we want to be pretty much sure that what we write makes sense. What we write makes sense.
Not exactly lean startup when you handle business money necessarily.
Yeah. Publish coding get rich.
This was a stupid logic, but it was.
No, we can get
boards should get boards.
Yes.
Right.
But you want a list of them.
Yeah. Okay. A list.
So you list diamonds board.
Okay, so a board is just a row, basically.
Yes.
Row ID.
Yes.
Is that it?
Yes.
So you need to add curly brackets or something.
No, we need to write the list in front. Then diamonds and board.
Yeah.
and then it complains because we're not returning it. But
And now just
how do
I do a query like this? Like,
as a things to mention, what with this query will return is a list of row IDs.
Yeah.
And probably that's not what you want in the client side. So
well, it depends on what support you have on the client side.
Yes, of course. But we can also actually something that will come later. We can write both and have like a star syntax that returns the whole row. So
here,
we can
like list board star.
No, we don't have it yet.
Okay. It comes later.
So now we can just get board and get the select. But now we can talk a bit. Okay, you can try to call it.
Yeah, but now I don't get the list. I just get one row of this. I need to convert it to a list, right?
If we want
to
a list,
array,
we need the at star, so asterisk.
And it will automatically become a list of at
and star. And semicolon.
Where
at the end.
Here.
It doesn't complain anymore.
Nah.
So
fantastic.
I
don't need to. I could have something here like name equals blah blah blah, but we don't need to do that because I'm returning all the boards.
Yes, or for example, if you want to have the timestamp of when the board was created, then you can go around the list getting all like, if you are paging, you can get 25 most recent boards given a time, and so you can create paging and stuff like that.
So, at star coerces the table to a list of boards. That's cool.
Actually we have also like a nullable type, so you can maybe you don't have a board, maybe you have one. If we return a board, not a list, we can okay, let's say that we want to get a board, a specific board, but we do not know if it exists. If we do at, it fails if there is no board. But what we can have is like board. We can say
one thing is, for example, player. You might check if the player already exists.
A query get player.
And provide a name. You can, since it's indexed or keyed on name, we can do a check then. Return. And this is only single player. So
we need the curly braces.
Parentheses. So
and this I'm stating that I have a player. So having at means that I'm sure that there is a player here. If we do at question mark, this is a nullable. So it can be like either a player, either null.
So what happens here if I call from the client, get player Mickey Mouse, and Mickey Mouse is not playing? It will be crash.
It returns not found. I mean,
but now it returns an error. Mickey Mouse, because it assumes that you will find the match.
Yes. So what we need to do is to add a question mark and verify that that player exists. So if we make a question mark, this can return null or the player. If we want to verify, for example, if now we want to check that actually there is a player or not, we can make if statement. So if there is a player, if the player is equals to null.
Do we do like in Java, put it in a variable first, like?
Yeah, I do it, but you can.
Like this, and if parentheses p, curly brackets.
Return
p. Do I need to have it? Well, it could be or just a new line.
Yeah, and
how do I do null? Null.
I mean, if you return p, it already returns either the player, either null. So you actually don't need this if. But if we make
wrong type if expressing player instead of boolean.
Yeah, we have to check equals to null, for example. Actually, we have also
like this.
Yeah, we also have a not p, means like not null. If it is actually if different from null.
I could have like this as well. It's a magic word, null, or.
Yes, this is fine, but here we are checking if player equals to null. So we have if player is different from null, we want to return the player.
So it proves you can do bugs here as well.
Okay. But actually, this code is not needed. This is.
No, I understand. You can optimize this. I'm now checking the syntax.
You can
shit,
just
right?
return p.
Yeah, I understand.
But we can keep it. You can keep it. And I will show you when this is useful. If instead of a query we make a function.
Here, like
yes,
a function call.
Yes. No, instead of query, the word query, we say function.
So it's only run from inside RELL.
Yes,
programs.
and the function is get or create player. So insert or like if does not exist, I want to create it.
In common Lisp we call it ensure.
All right.
Ensure player.
We get if equals to null. We can return. We can still return it.
Then we create player.
Yeah,
right?
return create player.
Then we create. Oh, then I need the pub key.
Yes, of course.
Create. Should I use both for selection?
You
Doesn't
can, but
matter.
since they're both primary skills.
We know that by definition we don't have. So create player. Name. Okay. Semicolon.
And then we return it.
Here. Why does complain? Return type mismatch player instead of
yeah, that's correct. So we can return. We can
function should return.
No, we have to bang operator. So p has the double exclamation mark to say I'm sure that this is not null. So if we put two exclamation mark, what we are doing is like since p may be null because we said the question. Yes.
Complain. Player instead of unit.
Okay.
It's something with a unit.
Yeah.
We haven't specified what we
return. Have to return player.
Maybe if I just fix return player instead of unit.
That's a player.
Do I need to?
Yeah.
Huh.
Yeah.
Yeah, maybe you can.
Yeah, no, in the function we need to set what we give back if we give back something. In query you can automatically infer. But in function, since we need to validate into other RELL parts, like the function can be called by the RELL code.
Yeah.
So we need to know what it returns. While query can be like a be left to what it is because we actually don't need this safety bit. But although it's recommended, I actually use it in query. I say what I'm sending back. We have one last type of cardinality operator. So we can have 0 or 1, which is the question mark, at the question mark. We have at. Maybe we can write them just as a comment, so we can.
Cardinality.
Yeah. At the question mark means 0 or 1. At means exactly 1.
Okay. Exactly 1.
And then we have at star, which means from a list from 0 to n class objects of the same type, of course. And then we have at plus, which returns a list of 1 to n elements.
One to n, not 0 to n.
Yes, you cannot have 0, you cannot have an empty list.
Because that's null.
No, just an empty list. If we don't want to get an empty list, we fail.
Aha, okay. If you use this operator, you cannot return an empty list.
Yes, exactly.
You will get a list that has values. But what if I want to can have is that with a star if I want to have a list with
Also 0 values, yes.
So this means a list, right?
Yes, this is also, you can say list T. That's like of the template list. Yeah, that's
for
also
both,
list.
Right?
Yes.
Okay, so that's how to write queries.
Yes.
Would be cool to see a little bit of the logic. Wonder if we should take a look at you send the code, or we switch to the camera, or
we can maybe
extreme zoom in or something like that. Or
what kind of logic we want to code. Maybe we can code it ourselves. We can code it now.
code it now. Okay, what kind of logic do we need? I mean,
Update a name, maybe.
yeah, detect wins, but that's basically look through the rules of tic-tac-toe. And you have the source code to show how we can do it.
We can.
What more?
Maybe we can start
Logic.
playing around. I mean, really, like
Or have we explained the language now? Basically,
actually, we made a mistake here in this code. When we call the function join player, join board here.
Join board. Yeah.
We should We should change the state of the board, because now our board is full. Like we have 2 players. We can start to play.
Yeah.
So what we have to do? We have different ways to do that.
So we need an update operation on board.
Yes. So update operations.
Yeah. I guess that we start with board and some magic.
And update in front.
Really?
Yes. So we say we want to update the board. And then you select the board you want to use. So board name.
Board name. Curly brackets.
At operator curly bracket. Because you want only one board to be changed.
Yeah. Board name.
And then you can, after the closing curly braces, you can open a circle parenthesis and set a dot state.
Yeah.
I think it's 1. Oh.
Yeah, probably 1. Table with 2 players.
This is legit, but we can do it in a much more simpler way.
Simpler than this?
Yes. You can
How can you do this simpler?
Because we already have the board here, so we can just say b dot state plus 1.
I retrieved the board here.
But it was good because so we can see that we also have an update operator.
Yeah.
That's even simpler.
This is so pretty, fantastic. I get tears in my eyes. I'm not kidding. This is nice, yeah.
Yeah, this is pretty it. Maybe next time we can do the logic or do something more complex.
Yeah, maybe I'll do a chess game. To pick something easy.
That sounds cool. Actually, we actually try to do the checker game, and we are like deploying it in these days. And yeah, the reason why I didn't want to go for checker is because the rules are so big, like so many, so complex that the majority of the time goes into coding them.
So
but it's totally possible.
I mean,
so I know that you as a CEO, you have a lot of time.
Yeah, exactly. Yeah. But detecting wins here is basically checking the It's not too many coordinates you can win. You can do it manually, right?
Yeah,
Check
so I really did it
this
manually.
row, this.
I want to say it took me 16 lines, including the declaration of the function is win.
16 lines of code.
Yeah, they're here.
For the game logic.
Is win. And is a function. Checks the line, checks the vertical, checks the diagonal. I can give you the link, maybe.
Yeah, show it. 16 lines of code. You don't believe me? Check the repo, I guess. Yeah, this is good.
Okay.
Really good.
Do we still have a job?
Yeah, you have a absolutely. But I will only pay you per line of code.
Okay, so fuck my life. I think that's probably how this.
But I can buy you lunch.
Okay, that's
I'm a nice guy.
How many?
So. Okay.
Okay.
Thanks for now.
Yeah, maybe we should make others.
Yeah.
Maybe next time we should learn something else.
Yeah, next time decentralized social network or a new kind of democracy implementation for an African country. Amazing.
Okay.
Okay. Thank you.